So my name is Iodice, and I'm a senior software engineer for the machine learning group at ARM. I joined ARM 4 years ago, and since the beginning, I have been working on enabling, deploying, and optimizing intelligent vision applications on ARM-based platforms. And today, I have a great pleasure to talk about an efficient and fast algorithm which can be used for accelerating our convolutional layers in our convolutional neural networks. The name of this algorithm is Winograd filtering algorithm. So let's start to see the agenda for today. After a very brief introduction about ARM, where I'm going to spend just a few words about the company I work for, I'm going to deep dive into the world of convolutional neural networks, presenting an overview of the current trends inside the convolutional neural networks used for object recognition tasks. After that, I'm going to spend one section talking about potential optimizations for convolutional layers when the convolutional layer is implemented with GEMM, so with a matrix multiplication. In this section, we are going to see what is the memory coalescing and also the important role of the local group size, which plays a significant role, especially if we deploy a matrix multiplication on a GPU, especially on the embedded GPU. However, the main section of this talk will be about the Winograd filtering algorithm. And this part essentially will be the core part of this presentation. I'm going to present a mathematical background to understand how Winograd works, and also how to demonstrate the complexity reduction introduced by Winograd. We'll see the algorithm design, and in the end, the performance achieved on our platforms.